Hello, welcome to the video of session 2 of module 2 filtering of long data sequences of the subject digital signal processing prescribed for 5th semester electronics and communication engineering students. Learning objective of this particular session are filtering of long data sequences. Then we will be checking the linear filtering here. Then we will be considering block convolution, and at the end we will be considering overlap save method. Filtering of long data sequences. Again here what we are doing is we are considering a linear time invariant system with system impulse response h of n, to which we are applying the input x of n. Output y of n is the linearly convoluted output of or linear convolution of x of n with h of n. So in time domain, the output is considered as linear convolution. This y of n is linear convolution of x of n and h of n, which is also called filtered output. So here our LTI system is acting as a filter. Basically, in real-time signal monitoring application, whatever the input x of n we are considering will be of huge length. So it will be very long. So for linear filtering using DFT, the signal should be of smaller length because of the memory requirement of the DSP processor. So it is difficult for us to use DFT directly for finding linear filtering of long data sequences. So what happens in real time, the data acquisition delay as well as data processing delay occurs. So from input to output, it takes more delay which is not required for us. So all n inputs should be available for making use of FFT to find DFT, and complexity of endpoint DFT is n log n, which is more, so data processing gets delayed. If our endpoint DFT, if the value of n is too large for long data sequences, then there is a significant delay which acts as hurdle for real-time processing. So the strategy we will going to make use here is, what exactly we are doing here is, we are segmenting the incoming signal, that is x of n. We will be considering the x of n, and we will be segmenting the inputs into fixed size blocks before processing that particular input x of n. Then what we will be doing is, we are considering each blocks of data whatever we are segmented separately, and we will be computing linear filtering using DFT, or that is using FFT we will be finding DFT based linear filtering. Then we will be obtaining blocks of output data or blocks of outputs. At the end what we will be doing is, we will be taking all those output blocks and we will be fitting together such that overall output should be equal to the linear filtering of our whatever the x of n we will be going to take directly. Main advantage of this particular method is the sample output, whatever the output from our LTI system will be available in real time, which is on block by block basis. So goal, actually the main aim of this particular method is getting the FIR filtering. That is, our LTI system is acting as FIR filter, and Y of n is the output, FIR filtered output, which is nothing but linear filtering, linearly filtered output, that's x of n convolved with h of n. There are two methods or two approaches for a real-time linear filtering of long data sequences. अथवा long data inputs. One of that methods is overlap add method and overlap save method. Here we will be assuming certain things. First assumption we will be making it as length of the FIR filter or the FIR filter's impulse response length will be M. We are assuming this, and we will be assuming length of each blocks as L. So now let us take overlap save method. As we know, two approaches of filtering of data, long data sequences: overlap save method and overlap add method. As we are doing these two methods just by segmenting into blocks and proceeding with the next further procedures. Like after dividing into blocks, we have to um, convolve with the system impulse response, and whatever the convolved output, blocks of convolved output we will be getting, that will be uh, overlapped, and then we will be doing the saving operation or adding operation depending upon the requirement. Hence these two procedures are called block convolution, because we are doing this block by block. And as these two methods are first, the values of the incoming signal or input signal is segmented into blocks, this procedure is also known as segmentation convolution. So in this session, let us concentrate on overlap save method. So as we discussed yet, this overlap save method is one of the linear filtering method where the incoming signal is segmented into blocks. So what we are considering is, we are considering a long data sequence which is x of n. Okay, in this x of n we are considering as which is having ls number of samples. This ls is length of the long data sequence x of n. So our x of n is having the samples x of 0, x of 1, x of 2 up to x of l minus 1. So length of x of n is ls. And as we considered the assumption, length of the FIR filter's impulse response h of n as m, this h of n sequence is having the samples h of 0, h of 1, h of 2 up to h of m minus 1. So there are m number of samples in system impulse response or FIR filter's impulse response. So according to the strategy, what we have to do is, we have to take the incoming signal or input signal x of n, which is longer or which is having more number of samples. Then we have to divide into number of blocks. So x of n is what we will be dividing this x of n into number of blocks, which is xi of n. And the blocks whatever we have divided, each block is convolved with the impulse response h of n to obtain the outputs yi of n. So yi of n is nothing but convolved output of xi of n and h of n. Then at the end what we have to do is, we will going to consider all the outputs of yi of n and they are combined to get the final output. Here how we will be going to combine is, we will be overlapping and saving, and also, and this is also known as overlap and discard. That means while combining the outputs, blocks of outputs, we will going to save certain samples. In other words, we will going to discard some samples to obtain the final output, which acts as if our x of n is directly convolving with our h of n. So now let us consider an example. Here our incoming sample or input sample x of n is having the length 18. So our x of n is having the samples x of 0, x of 1, x of 2 up to x of 17. And length of h of n we are considering as m, which is equal to 4. So our h of n is having the samples h of 0, h of 1, h of 2 and h of 3. So now what we need to do? We have to make the length of each block as length of block plus that is x of n plus that is xi of n plus length of h of n minus 1. So we have to do n point linear convolution. So our value of n is l plus m minus 1. So m we have considered as 4 and we are assuming the value of n as 7. Obviously we have to make length of the block as l. So it is n minus m plus 1. L is 7 minus 4 is 3 plus 1 is 4. So we have to divide this x of n into blocks. See how we are dividing here. So first block in overlap save method, how exactly we are doing is first m minus 1 samples we will going to take is zeros. These are padded zeros. So we have to pad L minus 1 number of zeros in the beginning of first block. Then we have to take the input samples such that the value of n is 7. So first 3 are m minus 1, that is equal to 4 minus 1. 3 appended zeros here. Then remaining 4 are incoming samples x of 0, x of 1, x of 2 and x of 3. So next block should be consisting of first m minus 1 samples are the repetitive samples of last m minus 1 samples of the previous block. That means, see here value of m is 4, no? So first 4 minus 1, that is 3 samples are zeros, appended zeros. Next, in the second block, first 3 samples, that means m minus 1 samples are last m minus 1 samples of last block. That means x1, x2 and x3. We can observe here. So I have highlighted in blue color. So this first 3 are repetition of last 3. X of 1, x of 2, x of 3. So here we have stopped, right? So x of 3, next is x of 4, x of 5, x of 6 and x of 7. And you can observe here each block is having the length which is equal to 7, that is n. So now what will be the next block? Obviously first m minus 1 samples of the next block will be m minus 1, last m minus 1 samples of previous block. That means x5, x6, x of 7. See, x of 5, x of 6 and x of 7. Next, the remaining values x of 8, x of 9, 10 and 11. Similarly, we have to take the next block. Observe, first m minus 1 are the repetitive form or repetitive samples of last m minus 1 samples of previous block. That is x of 9, x of 10 and x of 11. Remaining values we have taken directly x of 12, 13, 14 and 15. So we have to do this for our next block also. See, x13, x14 and x15 we have taken, but the length of this is 18. So this is still x of 16 and x of 17, but we have to make the length of each block as 7. This makes only 5. So we have to append 2 more zeros here. Okay. And last m minus 1 is, that is also including this part. So we are taking one more block. X6 of n will be x of 17 and 0 and 0. But we have to make length of this block also as n. So we are appending 4 zeros here. So it is x of 17, 0, 0, 0, 0. So this is the first step we are doing. That means we are considering the long data sequence x of n, and we are dividing these samples into number of blocks. Okay, how we are dividing? First block is having first m minus 1 samples which is appended with 0, and the remaining values are from input sample. Second block will be consisting of first m minus 1 samples are repetitive form of last m minus 1 samples of previous block, and we will be taking the next x of n's values, and third block will be the consisting of first m minus 1 samples are the repetitive form or copy of last m minus 1 samples of previous block. So this will be repeated till we obtain this particular thing. What's the next step? After dividing the long data input sequence into number of blocks, we have to take the impulse response whatever they have given, and we have to check for length of h of n, whatever it may be, the length of h of n. We have to make length of the h of n that should be equal to length of the block, that is n, because we have to convolve these two, these values x of xi of n, we can say. See, x1 x1 of n, x2 of n, x3 of n, x4 of n, x5 of n, x6 of n. Now we will call this as xi of n. Here our I value is varying from 1 to 6. So we are convolving this xi of 6 with this h of n circularly. As we discussed in the previous session, we are making use of circular convolution here such that we can obtain linear convolution. Basically, our goal is to obtain the filtering or linear filtering. Linear filtering is nothing but linear convolution. So, that linear convolution we are obtaining here by using circular convolution block by block. So, now what we are doing is we are making the length of impulse response which is equal to length as the length of the block just by appending L minus 1 number of zeros to this M samples. That means H of n will be having H of 0, H of 1, H of 2 and H of 3. These are the given samples to which we are appending L minus 1, that is 4 minus 1, which is equal to 3 zeros here. These 3 are the appended zeros. So now next step is to find blocks of output. That means outputs yi of n. We will obtain yi of n by circular convolution of the block of input with the impulse response. As length of the block we are considering here as 7 and we are making length of impulse response as 7, we are doing 7-point circular convolution to obtain blocks of output. That blocks of output is of length 7. So, if we do 7-point circular convolution of x1 of n with hn of n, h of n, so our y1 of n is 7-point circular convolution of x1 of n and h of n. We obtain 7 samples in this output block y1 of n, that is y1 of 0, y1 of 1, y1 of 2, y1 of 3, y1 of 4, y1 of 5 and y1 of 6. You can see the color difference here. This y1 of 0, y1 of 1 and y1 of 2 are the output samples because of the convolution of 3 samples of IH of n and the first 3 appended zeros to our input block. So next is y2 of n. Second block of output we will obtain by 7-point circular convolution of x2 of n into h of n. So here y2 of 0, y2 of 1 and y2 of 2, these are the convolved output of the previous m minus 1 samples with the first m minus 1 sample of h of n. So we are representing these in red color, and these are for the next real-time values. So similarly, y3 of n will be 7-point circular convolution of x3 of n and h of n. So which is having y3 of 0, y3 of 1 up to y3 of 6. Similarly, we obtain y4 of n by 7-point circular convolution of x4 of n with h of n. y5 of n is 7-point circular convolution of x5 of n and h of n. And last, because we are convolving the last block of input with the impulse response h of n to obtain y6 of n. And we can observe here y6 of 0, y6 of 1 and y6 of 2. These are the output samples obtained because of the 7-point circular convolution of the block, sixth block of input, where the first three samples are repetitive form of last three samples of the previous block. So we have taken this in red color. And y6 of 3 is because of the last sample of the incoming sequence, long sequence, and the yellow color samples are representing, these are the values obtained because of the appended zeros. So you have to concentrate on these colors of these samples. Whatever the values we have samples we have represented using red color. Whatever the values we have represented using green and the yellow color. So final output. Observe what will be the final output. As we took in the beginning as a strategy, we have divided into number of blocks. Then we made length of h of n as length of block of input. Then we obtained circular convolution. We were making use of circular convolution to obtain the blocks of output. Now we have to combine the blocks of output, or we have to fit this outputs into a single or total or final output. How we have to do? We have to overlap and we need to save some values. Otherwise, we have to overlap and we need to discard some values. You can observe here. See, whatever the samples which are represented in green color, we are saving that. Observe y1 of 3, y1 of 4, y1 of 5, y1 of 6. Next, y2 of 3, y2 of 4, y2 of 5 and y2 of 6. Next, y3 of 3, like that. So, till here, y5 of 6 and y6 of 3. And as these are, see, except this first block, the remaining blocks are having first m-1 samples, which are the results of the values which are repeated samples of previous block. So we are not considering these appended values. And see, y6 of 4, y6 of 5 and y6 of 6 are, these are the zeros which are appended just to make the final block of input as, which is having the length, which should be having the length, which is equal to the other blocks. So this is the final output. So now let us do one thing. Let us take one illustrative example so that we can understand this particular overlap save method in better way. So before that, let us see how exactly we are doing. We are considering a long input signal. So it is having this length, and we will be dividing into L blocks, L number of blocks. Block of length L. So that means values of this block, there are L number of samples here. So in L samples, this one is L samples. This L sample will be taken from incoming signal, this is x of n, to which we are appending m-1 zeros in the beginning itself, in the first block. Okay, see, first m-1 which is represented in green color, then remaining remaining L values are from x of n. That we will be calling it x1 of n, x1 of n. See, Next block of data is x2 of n, which is having m minus 1 samples here, which are taken from m minus 1 previous samples or last m minus 1 samples of previous block. So here, whatever the values we are repeating here, and remaining L values from our x of n, such that m minus 1 plus L, that is L plus m minus 1. So this particular length is n. Similarly, our x3 of n we will be dividing with such that m minus 1, last m minus 1 sample of previous block is taken as first m minus 1 points for samples, then to which we will be taking L samples from the x of n. Okay, this is how we are dividing into blocks. And this blocks, to this block we are convolving to obtain linear convolution or linear filtering with h of n, impulse response. See, output signal blocks we will be obtaining like this. Because of x1 of n, circular convolution with h of n, we obtain y1 of n. And n point circular convolution of x2 of n with h of n gives us y2 of n. N point circular convolution of x3 of n with h of n gives us y3 of n. These values are because of these overlap values. So what we are doing is, we are overlapping these values such that we will going to discard this. These are the repetitive. So we will not going to lose anything. Okay. So we will be considering these values, these L samples, these L samples and these L samples to obtain the final output. So now let us take an illustrative example to understand this better. So here, first example, let's consider a FIR filter with impulse response h of n, which is equal to 3, 2, 1 and 1. If the input sequence x of n is 1, 2, 3, 3, 2, 1, minus 1, minus 2, minus 3, 5, 6, minus 1, 2, 0, 2 and 1. Find output using overlap save method. Assume length of block is 9. So this is the given statement. So let us start solving this. They have given us to assume the length of block is 9. Okay. So we know length of the block is given by n, which is 9. And input what they have given is this 1, 2, 3, 3, 2, 1, minus 1, minus 2, minus 3, 5, 6, minus 1, 2, 0, 2 and 1. So length of the input signal, we are considering it as LS, which is 16. So there are 16 samples. Now h of n, they have given it as 3 to 1, 1. So value length of this h of n is 4. This m is equal to 4. So what should be our length of block n? N they have given us to assume as 9. So L plus m minus 1 should be 9 and m value is 4. Obviously our value of L should be n minus m plus 1, which is 6. Now what we have to do? We have to take that x of n and we have to divide this x of n into number of blocks. So first block, as I told, we have to consider or we have to append m minus 1 samples or 1 zeros in the beginning for the first block. That is 0, 0, 0 and these are the values, samples of x of n. 1, 2, 3, 3, 2, 1. Next x2 of n. See, we can observe here these three values 3, 2, 1 are from previous samples. Okay, and these are the remaining values, next values of x of n. Next, see, first three samples are, so next block is x3 of n, which is having 5, 6 and minus 1. These are the samples which are repeated as the last three samples of the previous block, and 2, 0, 2, 1, 0, 0. These are the values of x of n. Next, x4 of n is 1, 0, 0 and remaining are the appended zeros. To make the length of this particular block as 9. Next, what is the step? We have to make length of the given impulse response, which is to be equal to the length of block of input. So that is E9 they have given us. So what we have to do? We have to make length of h of n to be 9. But they have given the length of h of n, or the given h of n is having 4 samples. To make totally 9 samples in that, we have to append 5 zeros. Like this. 3 to 1, 1 they have given. We have to append 5 zeros at the end of this h of n. So next step is we have to convolve each block of input with the impulse response with appended zeros to obtain block of outputs. So first block of output y1 of n can be obtained by 9-point circular convolution of x1 of n and h of n. So if we convolve x1 of n block of input, first block of input with h of n, we obtain 7, 3, 1, 3, 8, 14, 18, 17 and 13. How exactly we have done this 9-point circular convolution is, we have taken 9 samples of x1 of n and we have generated square matrix that will be multiplied with the column matrix h of n to obtain the circularly convolved output, which is nothing but the linear filtered output, which is also equal to the linear convolution. Similarly, we will be finding 9-point circular convolution of x2 of n with h of n, which we are going to get it as 18, 17, 19, 4, minus 5, minus 13, 6, 23 and 11. Y3 of n can be obtained by 9-point circular convolution of x3 of n and h of n. We obtain the outputs or samples of y3 of n as 16, 28, 14, 15, 9, 7, 9, 4 and 3. And y4 of n we will be obtaining by 9-point circular convolution of x4 of n and h of n. We obtain the samples, output samples as 3, 2, 1, 1, 0, 0, 0, 0 and 0. So these are the blocks of output obtained by convolving xi of n with h of n with 9-point circular convolution. So what's the last step? We have to overlap and we have to keep some values, or we have to overlap and we have to discard some values. So the output of the FIR filter is, see what we are doing? We are keeping the values which we have highlighted with green color. The red color samples are results of the circular convolution of the blocks of input, where the number of samples which are repeated form of the previous samples. So we are neglecting these values and we are considering these values. So what is the final output we will be obtaining? Y of n is equal to 3, 8, 14, 18, 17, 13, 4, minus 5, minus 13, 6, 23, 11, 15, 9, 7, 9, 4, 3 and 1. And you people can observe one thing here. Though we have not done the linear filtering just directly by considering x of n with h of n, instead we have divided x of n into number of blocks of data, that is xi of n, and we are performing 9-point circular convolution of individual blocks with impulse response to obtain the output blocks or blocks of output data, and then we will be combining those output blocks to obtain the final output. So here, because of the faster operation of DSP, we can see all these are available block by block. So now let us consider the second example for better understandability. Okay, this is another example of same kind. they have given the impulse response as 1, 1, 1, and the input sequence they have given it as 3, minus 1, 0, minus 3, 5, 6, minus 1, 2, 0, 2, and 1. Find output using overlap save method. Assume length of block is equal to 5. So now let us solve this example. So here, so the given value of n, that is length of block is 5 here. X of n, whatever they have given is, so input sample, whatever they have given is x of n is equal to 3, minus 1, 0, minus 3, 5, 6, minus 1, 2, 0, 2, and 1. So total there are 10 samples here. So LS we will be considering as 10. So next, length of the given impulse response is 3. That is m is equal to 3. So length of the block they have given us to assume as 5. Obviously from this, if you obtain for value of L, we obtain the value as 3 itself. So that is 5 minus, sorry, 5 minus 3, that is 2 plus 1 is 3. So now we have to divide the given input into number of blocks. See, first m minus 1, 3 minus 1 values or samples are to be appended zeros for the first block. Then we are going to take the samples from x of n. x2 of n will be having m minus 1. That means last two values to be repeated as first two samples of next block. See, here we can observe. We have highlighted using blue color. Similarly, next block of input is 3, 2, 0, 1, 2. These 3 and 2 are the repetitive values of the previous 3 minus 1 sample. That means 2 samples. So, fourth block of data is 1, 2, 1, 0, and 0. So, this is how we have to divide into number of blocks. Then next step is we have to consider our h of n, and we have to make the length of h of n, which is to be equal to length of these blocks. So we have to append L minus 1 number of zeros to this h of n to make length of this h of n, which is equal to 5. So they have given it as 1, 1, 1, to which we are appending 2 zeros, 0, 0. Now we have to find output blocks, that is yi of n, by 5-point circular convolution of input blocks, that is xi of n with h of n. So our y1 of n can be obtained by 5-point circular convolution of x1 of n and h of n. So we have to generate square matrix of x1 of n, to which we have to multiply with column matrix h of n. So we obtain minus 1, 0, 3, 2, and 2. So next is y2 of n, that can be obtained by 5-point circular convolution of x2 of n with h of n. So it is 4, 1, 0, and 4, 6. y3 we obtain by 5-point circular convolution of x3 of n and h of n. So which is equal to 6, 7, 5, 3, and 3. Last block of data, output block is consisting of 1, 3, 4, 3, and 1. This is because of 5-point circular convolution of x4 of n with h of n. Now what we have to do? We have to consider the final output by overlapping and saving some samples. We have to save these samples which are in green color. That is 3, 2, 2, 0, 4, 6, 5, 3, 3, 4, 3, 1. So we have saved these values. We have overlapped these blocks of output and we have saved these values. And we are discarding The samples which are highlighted with red color. These red color highlighted values are because of the repeated samples of previous blocks. So this is the final output of FIR filter, or we can call this as linearly filtered output of this particular FIR filter for the incoming signal X of n with the if system impulse response H of n. So with this, hope we from this session we understood how to filter the long data sequences, and we also highlighted linear filtering concept. Then we come to block convolution method. So while discussing block convolution method, we considered overlap save method in this session. So let us see how we have understood the concept. Let's see some of the multiple choice questions. So first question is, overlap save method is one of block convolution method, segmentation convolution method, both of the above, or none of the above. Yeah, what is it? In the discussion what I said is, our overlap save method is a kind of linear filtering operation or linear filtering function of long data sequence. We will be doing this first by considering the input samples, and we are dividing into, or we are segmenting into blocks. So we are making use of segmentation operation as well as we are dividing into blocks. So this overlap save method is one of block convolution method, also segmentation convolution method. So obviously result is both of the above. See, we can observe here. Now let us go to the next question. Overlap save method is also known as overlap discard method. Is it true or false? As we discussed, first what we did is we divided the input samples into number of blocks. Then each block is convolved with impulse response to obtain blocks of output. Then what we will be doing is we are overlapping the blocks of output, and then we are saving certain samples. In other words, we are discarding certain values. So obviously our overlap save method is also known as overlap discard method. So the answer is true. Next question to be considered is, overlap save method is a real-time linear filtering approach. Is it true or false? Obviously, we will be going for linear filtering approach in real time, as the real time input signals are very large in length. So what we will be doing is we have to divide into blocks and we have to do block convolution. Then we have to overlap the signals and we need to keep some values or we need to discard some values. Obviously our overlap save method is a real-time linear filtering approach. The answer is option A, which is true. Now let us come to the last question of this particular session. So in overlap save method, which of the following is correct? So let us see the options. Overlapped values has to be added. Option B is, it will include adding a number of values in the output. It can be computed using linear convolution. All of the above. See, here overlapped values has to be added. No, we will not be adding any values. Directly we are overlapping and we are keeping some values and we will be discarding some values. So A is not the answer. It will include adding a number of values in the output. No, obviously. It can be computed using linear convolution. Yeah, it is correct. We are computing linear convolution using circular convolution. So only value option C is correct. So it can be computed using linear convolution is the correct answer. Hope you understood the concept which I have discussed in this particular session. For furthermore details, you people can refer to the book written by Prokis and Monolokis, which is Digital Signal Processing Principles, Algorithms and Applications, and the book written by Li Tan and Jin Jiang, the book Digital Signal Processing Fundamentals and Application. And also you can refer to the book written by Mr. Uday Kumar S, Digital Signal Processing. Thank you. Thank you very much.